Hello students. In alcohol, phenols and ether, in last sessions we completed two different process. One is called as an industrial preparations of salicylic acid with the help of Kolbe-Schmitt reactions, and number two is a Rimmer-Tiemann reactions to form a salicylaldehyde. Now today we onwards now the reactions of phenol under the title of reactions of phenol. We continue with our work is a reactions of phenol with zinc dust. It's a very simple reactions. Once again, when phenol is converted into zinc, converted with the help of zinc into benzene. So it's a one type of reduction reaction when we get a product benzene. Benzene is our product. This is phenol, right? So phenol is converted to benzene on heating with a zinc dust. So the reactions of means any phenolic group, any phenolic. What is the meaning of phenolic? When OH is directly attached with the phenyl ring, is always reduced with the help of zinc, and it's converted into zinc oxide and aromatic compound that we have to form. For your self practice, if our compound is 2,4,6 trinitrophenol, or if our compound is parabromophenol or catechol or resorcinol or hydroquinone, whatever the compounds, if it reacts with the zinc, so at that time simple zinc is attached with the oxygen and this hydrogen is attached with the phenyl ring and is converted to corresponding compounds, right? So this is about the reactions of phenol with zinc dust. Then number 5th reaction is called as an oxidation reaction. The meaning of oxidations mean either we have to add oxygen or to remove hydrogen is called as an oxidation reactions. So here in this case, oxidation of phenol with the help of chromic acid. This chromic acid is produced with the help of Na2Cl2O7 and H2SO4. The reactions between sodium chromate and H2SO4, they convert into chromic acid H2CrO4, where the state of oxidation state of chromium is +6, and they oxidize phenol, right? They oxidize phenol and produce the conjugated diketone. The meaning of conjugated diketone is like that. This is double bond and conjugated, double single double likewise. So this is called as an para-benzoquinone. This is para-benzoquinone. So once again, when phenol is oxidized with the help of chromic acid, produce conjugated diketone known as para-benzoquinone. In the presence of air, sometimes phenol is slowly oxidized into dark colored mixtures containing quinones too. So this is all about the reactions of phenols. Now we move to the another portion, and this portion is called as some commercially important alcohols, because in our textbook, because it's a descriptive portion, so I explain with the help of your textbook. So now our next point is the some commercially important alcohols. So in our textbook they give two different alcohols, methanol and ethanol. They are among the two commercially important alcohols. So first we move to the methanol. We know that the methanol in CH3OH is also sometimes is called as a wood spirit too, because it was produced by a destructive distillations of a wood. That's why the name is called as a wood spirit. Today most of the methanol is produced by a catalytic hydrogenations of carbon monoxide at high pressure and temperature in the presence of zinc oxide and Cr2O3 as a catalyst. So first we have to take a methane, and the partial oxidation of methane is converted into CO and H2. Sometimes this mixture of CO and H2 is also called as a water gas, and now this water gas is reacted in presence of ZnO and Cr2O3 as a catalyst at near about 300 to 400 degree centigrade temperature and 200 to 300 atmospheric pressure. It's converted into methanol. This methanol is a colorless liquid and boils at 337 Kelvin. It is highly poisonous in nature And ingestions of even small quantities of methanol can cause blindness, and large quantities cause even death. So methanol is used as a solvent in paints industries as well as varnish industries, and chiefly for making formaldehyde. Sometimes for making formaldehyde, what is the meaning of making formaldehyde? If the formaldehyde is formed, so formaldehyde is used for the preservative for biological specimens and bakelite melamine formaldehyde. So to form such a type of polymer, so it's required formaldehyde, and to making formaldehyde, it's a requirement of methanol. So for denaturing of ethanol, so at that time we have to use called as a methylated spirit too. In the case of antifreeze for automobiles, radiators, substitute for petrols, perfumes in drugs industries. So these are the various uses of methanol. Now we move to the another portion, and this portion is called as an ethanol. So what is the meaning of ethanol? Here the ethanol means C2H5OH is obtained commercially by the fermentation. This is already you have to study it in standard 10. The oldest method is from sugars. The sugar in molasses, sugar cane of fruits such as grapes is converted to glucose and fructose, both having the same formula C6H12O6, but glucose having a aldehyde group and fructose having a ketone group. So this particularly aldehyde is one type of glucose is called as an aldohexose, and fructose is called as an ketohexose. So in the presence of enzymes invertase, glucose and fructose undergo fermentation in the presence of another enzyme, zymase, which is found in the yeast. So first we have take a sugar, and the hydrolysis of the sugar means we have to use invertase is our as an enzyme, and is converted into glucose and fructose. And this glucose and fructose, when the help of this glucose is converted by zymase, right, is converted into ethanol and carbon dioxide. So here we get in this particularly ethanol, we have a 95% of ethanol and 5% of water. So it's called as an azeotropic mixture, or sometimes it's called as a rectified spirit too. So in why making, grapes are the source of the sugars and yeast. As the grapes ripen, the quantity of the sugar increases and yeast grows on the outer skin. When grapes are crushed, sugar and the enzymes come in the contact and the fermentation start. Fermentation takes place in an aerobic condition, means without the presence of oxygen, in absence of air. So carbon dioxide is released during the fermentation reactions. The excess of zymase is initiated one of the percentage of alcohol formed exceeds 14%. If air gets into the fermentation mixture, the oxygen of the air oxidizes ethanol to ethanoic acid, which in turn destroy the taste of the alcoholic drinks, because this is sour in nature. Okay. Ethanol is a colorless liquid with boiling point is near about 78 degrees centigrade temperature. It is used as a solvent in the paint industries and in the presence of a number of carbon compounds. The commercial alcohol is made unfit for drinking by mixing it some copper sulfate solutions to give it a color, and pyridine, a foul smelling liquid, is also known as a denaturation of alcohols. Nowadays, large quantities of ethanols are obtained by the hydrations of ethene. We know that when the hydrations of ethene, ethene in presence of acid catalyst, so it's converted into alcohol. This further various uses of this ethanol, they are the solvent for paints, liquor industries, varnish, dyes, cosmetics, perfumes, tinctures, cough syrups, right? Like Benal drink. Important starting material for the manufacture of the ether. This is the chloroform, iodoform, acetic acid, acetaldehyde. So it's a starting material to obtain this compound. Important beverages is also antifreeze in automobile radiators, solvent for the extractions and crystallizations, beverages like beer, rum, whiskey, brandy, right? Fuel in spirit lamps and stoves, antiseptic in nature. And today we in this COVID-19 stage, maximum we have to use such a type of alcohol, but mostly we have to use isopropyl alcohol. But ethanol is also used as an antiseptic or as a sanitizer to avoid the infections of this coronavirus. So these are the some commercially important alcohol that can be mentioned in our textbook. So this is all about the alcohol and phenols. Now we move to the another portion is called as an ether or the industrial preparations of ether. How to form a ether? So this is our next point. So in the case of ether, the preparations of ether, right? So now we start with the preparations of ether. Okay. So in this case, preparation of ethers. So the preparations of ether in presence of by dehydrations of alcohol or from alcohol. Okay. So the first portion is from alcohol. Okay. So what are the advantage or disadvantage of this method? From alcohol, and from alcohol our A portion by dehydration of alcohols. So from this method we have to get a symmetrical ethers may be prepared by the dehydrations of alcohol either in the presence of acid or in the presence of a heated alumina. So first we start with the acid catalyzed dehydration. So in this case acid catalyzed dehydration. So first we have to take a CH3CH2OH in presence of concentrated H2SO4. If we take a concentrated H2SO4 in excess near about 170 degrees centigrade temperature, we get a product is CH2 double bond CH2 ethene plus water. It's a dehydration of alcohol that we have to already studied in 2 times. One is the preparations of alkene and one is the chemical properties of alcohol. But if we take alcohol as an excess, not concentrated H2SO4, if we take alcohol in an excess, so in this case if we take ethanol in an excess level in the presence of concentrated H2SO4 at near about 140 degree centigrade temperature, so it's converted into CH3CH2O CH2CH3 plus water. So it's diethyl ether or ethoxyethane. The name of this compound is ethoxyethane. What is the drawback of this? This method always only gives a symmetric ether, not asymmetric ether is formed during this process. So what are the mechanism behind to form such a type of to form a diethyl ether? So in this case, first step, or sometimes it's called as step number 1. So step number 1 is like that. First ethanol CH3CH2OH, right? This CH3CH2OH is reacted with H plus, which is we get from acid, right? So this lone pair is attracted towards to the H plus and we get a protonated ethanol. And this protonated ethanol is sometimes called as an oxonium salt 2, protonated ethanol, or sometimes this is called as an oxonium salt. Okay. After the preparations of oxonium salt, the step number 2. Now this oxonium salt is reacted with a further mole of alcohol, CH3CH2OH, this is plus. Okay. So now this lone pair, they are attracted towards to this carbon, and at that time oxygen who gain the electron from this bonded pair between C and O, and they follow the SN2 reaction. Okay. So this reaction is a highly slow, it's a rate determining step, and we get a product is like that: CH3CH2O, CH2CH3, here H plus in water. So this is called as a protonated ether. This is called as a protonated ether. After the protonated ether, the another step is step 3. So which is like that: CH3, CH2, O, CH2, CH3, H. This is plus. Okay. Is further reacts with alcohols HO, CH2, CH3. Okay, and this is the fast step, and we get a product CH3, CH2O, CH2, CH3. Because this O is attached with the hydrogen at that time, the this bonded electron pair attracted towards to the oxygen, and we get a protonated ethanol too, CH3, CH2O, H, and this is protonated ethanol. So this is the mechanism behind it. So the yield of ether, this yield of ether, however, depends upon the nature of alcohols, whether primary or secondary or tertiary in nature. So in the case of primary, so for secondary alcohol they give such a type of product, and for the tertiary alcohol mostly gives the alkene. In the case of primary alcohols they give such a type of ether. In the case of secondary alcohol, our alkene is our major product, and this ether is our secondary product. So the order of the dehydrations of alcohol leading to the primary, secondary and tertiary in nature. And this method is generally not suitable for the preparations of unsymmetrical ether, and this method of preparations of ether is suitable only for the industry, since reactions condition must be carefully controlled. As such, as this method of little practical value in the laboratory. So this is all about the first process, and in next lecture we continue with the preparations of ethers with the Williamson synthesis process. Thank you.